Hello everyone. This is a recording for the second week tutorial for superstructure part, an example for dead load calculation. So in this example, we have to calculate the dead loads on an internal bearer, this one here, internal bearer of a flooring. So the question is, please find the permanent dead loads on the internal bearer. The given floor is a part of self-contained dwelling, so this is our flooring. The component of the floor is given as flooring, 19 millimeter particle board flooring. The unit weight is 0.13 kilonewton per square meter. The joists are 160 by 45 millimeter from radiata pine. The bearers is 250 by 65 timber radiata pine. No walls or partitions fall within the contributory area of the bearer. So the component of this flooring again, bearers, 1, 2, 3 bearers. We have joists. So the members in the short section are joists, and the flooring, which is particle board flooring. So this is the components of the flooring, and in the next slide we can see the components again. So we have flooring, we have joists, and we have bearer. So this is how the load transfer through the structure component. So from flooring to the joist and then to the bearer. So this is the load path of the gravitational loads. Okay, from flooring, then to joists, then to bearer. Okay, and here is the bearer. We need to find how much the dead loads on the bearer. So what to expect? What is the dead load on the bearer? The dead load on the bearer will be the flooring and then the joist and then the own weight of the bearer. So the dead load are on the bearer are consisting of flooring and then the weight of the joist and the weight of the bearer itself or self weight of bearer. So if we calculate these three components, we will find the dead load on the bearer, which is required in this example. Okay, so now you jump to the first step, the weight of the flooring or the own weight of the flooring. How to know the own weight of the flooring? The first is to know what is the material of the flooring, which was given as here, 19 millimeter particle board flooring. So 19 millimeter particle board flooring. Okay. Also, it is given the own weight of this material, which is 0.13 kilonewton per square meter. Okay, so now we know that each one, if we take 1 meter by 1 meter of the flooring, it weight 13 kilonewton. So this is mean, what is the meaning of one or the own weight of the flooring or the own weight of the material? Okay, so here is the flooring, and we need to design this internal or we need to find how much of the flooring transfer to this beam, which is the internal bearer. So the step now is the second step, or the next step is to know how much of the load transfer to the internal beam or the internal bearer. Okay. So this is how to do it. Each, as you can see, each beam, because the roof is supported by 3 beams, so each beam will carry half base basing from top, half base basing from bottom, so it will carry this area. So the internal beam will carry this purple area, and for example, the outer beam or edge beam will carry this area, and the other outer beam here will carry the remainder here, which is this area. So if we look at this on plan, if this plan, so we have beam, beam, and internal beam. The distance here is 2.4 given, 2.4 given. So the middle beam will carry half base basing from top, half base basing from bottom. So it will carry 1.2 from top, 1.2 from bottom. So the total will be 2.4. So the internal beam will carry this yellow area. So this is the area of flooring transferred to the bearer or the internal bearer. Okay, so this is how to understand how much of the load transfer from the floor to the beam. So if we go to the next slide, if we take this yellow area outside, so if we add the beam here in the middle, so this is our internal beam, for example. So this blue line is indication of the internal beam, and this part is half base basing from top and half base basing from bottom. So the total area, the width of the total area is 2.4 meter. This width, we call it as the load width of the bearer. So this is the load width of the bearer, or how much the bearer will carry from the load. So now we can easily find the weight of the bearer. So we can give it a symbol G. So G is indication of dead load. So dead load of flooring to the bearer will be equal to the own weight of the bearer of the flooring itself, own weight of flooring, times the load width. So G flooring will be 0.13, and be careful with the unit. So kilonewton per square meter times the load width. How much is the load width? 2.4 meter. This will give us the load as 0.31 kilonewton per meter. Okay. So I will just add another slide, a blank slide. So if we look at this step again, so we have G for the flooring will be equal to 0.13 kilonewton per square meter times load width, which is 2.4 meter. So the value will be 31 kilonewton per meter, because we have kilonewton per square meter times meter. So we will have meter with the squared. So the final value is kilonewton per meter, which is UDL. Okay, this is what we need to calculate. So we need to calculate the load on bearers in kilonewton per meter. Okay. So the load on the bearer need to be in kilonewton per meter. So this means that we convert the load on the flooring from distributed over area, kilonewton by square meter, UDL on area. 2, UDL on a line. Okay, or linear UDL. So this is our bearer here, and the G value is distributed over the length, which is in kilonewton per meter. So for beams or bearers, dead load needs to be calculated in kilonewton per meter. This is very important information you need to keep in mind. So this is how dead load on beam or live load on beam will be calculated in kilonewton per meter. So this is the first component of the dead load on the bearer, which is the on weight of flooring. The second component will be the weight of the joist. So as you can see here, these are the joists. We have a lot of mini joists in this example because the joists are members that help the bearer to carry the load of the floor. So the joists are given as radiata bind members. The dimension are 160 times 45 millimeter. So this one of the tricks here. And how much is the length of each joist? The length of each joist is 2.4 meter. So now, as you can see, we have some dimension of the bearer in meter and some dimension in millimeter. So we need to convert all the dimension to be in meter. So from millimeter to meter, you need to divide by 1000. From millimeter to meter, you need to divide by 1000. So this will be 0.16 meter, and this 0.045 meter. So the final or the dimension of the joist are 0.045 and 0.16. Okay, the material of the bearer of the joist, sorry, is radiata bind. The density of the radiata bind is 5.3 kilonewton per cubic meter. You can find this value at table A1 in the Australian standard 1170.1. So you need also to have access to this standard because we need it in the calculation of our load. And then we can find the value is 5.3 kilonewton per cubic meter. And now the second step is to know how much is the load of the joist. The idea here is to find the load of one of the joists. So we will find the self weight of one joist and then try to convert this to distribute it over the bearer. So how much is the load of one joist? The load of one joist will be the volume of the joist times the density. So as you know from physics, the weight equal to volume times the density. So how much is the volume? The volume will be the three-dimension width time depth time length. So it will be length time depth time width, which is 2.4 times 0.16 times 0.045. As you can see, all the units are meter. So the volume will be in cubic meter. And the density 5.3 kilonewton per cubic meter. So the final value will be in kilonewton. Okay. So if we do it here as well, so can insert another slide here. So to find the self weight of one joist or the load from one joist will be equal to the volume of the joist times the density of the joist. Okay, the volume will be the dimension of the joist, which is 2.4 meter, times 0.16 meter times 0.045 meter. So this altogether is the volume because this is the dimension of the joist given to us, 0.045, 0.16 meter, and the length is 2.4. Times the density. The density depends on the material, which is radiata bind. So based on the material given, it is 5.3 kilonewton per cubic meter. So the load of one joist will be the volume, again 2.4 in in cubic meter. So I just need only the units. So this will be a value in cubic meter times by 5.3 kilonewton per cubic meter. So cubic meter with cubic meter, so we will have the final value of 0.091 kilonewton. So the load of one joist only is 0.091 kilonewton. If we return back to here, so how many joists we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 joists. So one of the ways to find the loads is if we draw the free body diagram for the bearer. So this is the joists. So each one of this, we have 13 of them. Each load is 0.091 kilonewton, 0.091 kilonewton, and so on. So we need to convert that to a uniform load, equivalent UDL. So this is a very very basic method. It's just sum all the loads together and divide by the length, but this is not the best way to do it. So another way to do it is if we take the whole bearer and if we look at the distance between the joists. So each one of this is a joist. Each load is 0.91, 0.091, 0.091. So if we look at this this beam or this sketch, so this is our bearer, and each one of them are joists. So to convert this to a uniform load, or we can call it G from joists. So G from joists, instead of multiply the load from one joist times the number of joists, we will take one distance we know, which is the spacing between joists, and it is given to us in the example as 450 millimeter. So if we look at here, the distance between any two joists is 450 millimeter. So if we take any distance, 450 millimeter. So if you look at this distance, or this is spacing, how many joists in one spacing? One joist in one spacing. So all the time we have one joist in one spacing. So we can use this distance to distribute the load. So G from all joists will be 0.091 divided by 0.045 meter. So again, this is in millimeter, so we need to convert it to meter because all the units in meter, so it will be 0.45 meter. So here, just remove this one. So we have 0.091 over 0.45. So the top, the numerator is the load from one joist. I will remove it again. So to find the joist load, you need to divide the load from one joist. This is the numerator. divided by the denominator, which is the spacing of joists, or the distance between any two joists. Okay, so how much the load from one joist? 0.091 kilonewton. How much is the spacing of the joist? 0.45 meter. So now we distribute the load over the distance. So we have the final value as 0.201 kilonewton per meter. So this is what we need. We need to find the own weight of the joist, or the dead load of the joist, in kilonewton by meter. Okay, so if we look at that, the first two steps. So the first step we got, in the first step, what we got? In the first step, we got the flooring weight in kilonewton per meter. So if this our bearer, the length of the bearer is given to us as, if you look here, so the length of the bearer is 3.6 meters. So we have 3.6 meter. From the first step, we got G flooring as 0.31 kilonewton per meter. In the second step, we got the load from the joists as also uniform load. So G joists equal to 0.201 kilonewton per meter. So we have two values now, G joist and G flooring, and both of them are in kilonewton per meter. So you can sum them together to find the dead load on the bearer. So the third step is only self weight of bearer. We need also the self weight of bearer in as a uniform dead load. So it will be G self weight in also kilonewton per meter. So if you sum the three components together, so you will find the final dead load on the bearer. So the last step is the self weight of the bearer. The self weight of the bearer given to us as also rectangular section. The dimension is 65 millimeter width and 250 millimeter depth, and the length is 3.6 meter. This is the total length. So again, we have one dimension in meter and two dimension in millimeter. So we need to convert the dimension in millimeter to meter. So divide by 1,000. So this will be 0.25 meter. This will be 65 over 1,000. So 0.065 meter. So this is the dimension of the bearer. And here, the self weight of the bearer will be the cross section area times the density. Also, if we return back to the head of the question, the bearer was made from radiata pine, which is 5.3 kilonewton per cubic meter. So if we multiply the cross-section area times the density, we will get the load in kilonewton per meter. Here we need the self-weight in kilonewton per meter. That's why we multiply by the cross-section area. So cross-section area times density give you the self-weight in kilonewton meter. So how much is the cross-section area? The cross-section area is what we have got here, 0.25 meter, the depth, times 0.065, the width. So this is the cross-section area times 5.3. So you get the load as 0.086 kilonewton per meter. So now if we return back to the previous slide, after we did this calculation, we get the self-weight as 0.86 kilonewton per meter. So this is our third component of the dead load. So if I add another slide here to show you. So the final dead load on the bearer will be equal to G from the first component G flooring plus G from second component G joist plus G self weight of the bearer. So this is our three components. So the G total will be the summation of these three components, which is 0.31 kilonewton per meter, need to be in kilonewton meter. And second one is 0.201 kilonewton per meter. And the third one is 0.086 kilonewton per meter. So this is flooring, this is joist, and this is bearer. So G bearer total is equal to 0.597 kilonewton per meter. This is what we are looking at, what we need. So this is the final value of the load. And if we want to interpret that on the beam, so this is our beam, 3.6 meter. And this is the final dead load value, which is G equal to 0.597 kilonewton meter. And this is what we are required to calculate in this example. So the final dead load on the bearer is again the summation of three components, which are the flooring and joist and self weight of the bearer. And all the load again need to be calculated in, as you can see, kilonewton per meter. Because you cannot sum or add values with different unit together. So you need to have consistent unit, which is kilonewton per meter, to add the loads together. Okay. So that's all for second week tutorial. And if you have any question, guys, please let me know. And thank you.